G'day everyone, I hope everyone's well. So I apologise this video's taken a while to get out. I've been on holiday, there's family from over east been here, so haven't had time to get it out earlier. So because I'm a bit late, very Merry Christmas to everyone and a Happy New Year as well. And without further ado, let's get into everything so that we can get this one out of the way and focus on the next videos. So in the last video I just got the timing belt back together, and now we're going to move on to what you need to do with the oil pan. So you're going to need to reuse the 3VZ oil pan. The reason for this is the front suspension on the 4runner is different to the Prado. So before we swap on the 3VZ oil pan, we need to reroute the dipstick. So the dipstick in the Prado, it sits on the front of the 5VZ, and we want the dipstick to sit back. This is because the oil pan on the 3VZ, the sort of low spot is in the middle towards the back of the engine compared to the front on the Prado. So the way you do this is you need to drill out the dipstick port. Now the dipstick port already has a hole pre-drilled in the block. However, the plug that is pressed in by the factory has no hole through it. So we have to drill out this plug. So you can knock this plug out, it's just a little bit of an interference fit. But what I found out was you could actually use the hole that's been pre-drilled into the block as a guide for the drill. And so I just used this. You do have to be a bit careful, it creates quite a lot of swarf when you do drill. However, if you drill up through the block from the bottom, with the oil pan off of course, you're pretty much able to guide the drill perfectly dead center through this plug. And that'll mean that you'll be able to have a rear dipstick, which is really good. The dipstick tube is going to sit past the engine a little bit. You do have to make a bracket, which I'll show later on down the track. I just braced mine off the little sheet metal, it sits above the alternator, but you can do it however you want. If you do leave it loose, it's going to rattle around, so keep that in mind. I suggest not bracing it against the exhaust heat shield, since that gets hot and you don't really want that. But once you're happy with this and it's all done, you can go ahead and plug up the front dipstick hole. So this hole you can just plug up however you want. If you really want to, you could just JB weld over the top. No one's stopping you, it would be rough though. You could drill and tap a thread into it and just reef a grub screw into it just to keep it tight. I ended up cutting a bolt down, which I slid through from the bottom of the engine, and then I came down over the top of it with a washer and a nut, and this effectively locked it there indefinitely. And then before I put it on, I just used a bunch of gasket maker to create a seal and stop oil leaking out. Once you've plugged the front dipstick hole and the rear dipstick's been fitted, you can go ahead and put the sump on now. So I've always used gasket maker on sumps like this. Every now and again you'll encounter a sump that has a gasket from factory, such as my RD28 in the Patrol. I find gasket goo works perfectly, providing you follow the instructions, which is on the tube. Usually it's just throw the gasket goo down, assemble it wet, until you see the gasket goo start to seep out from between the sump and the engine block, and then you leave it for about an hour and then you torque it up to specification. Fairly straightforward. It's much easier to do this with the engine out of the car. I've done it with the engine in the car before, it's fine, you can do it. You do have to release the drag link for the steering on the 4runner to get to the sump. So yeah, just keep that in mind. It is a bit of a difficulty, and especially in rusty climates, your tie rod ends will tend to just absolutely seize in place, which you really don't like. So once the sump's been all finished off, you can go ahead and get ready to do the rear main seal. So you've got to drop the motor down off the stand, since you don't have access when it's on a stand. So I've gone in depth into rear main seals in one of my previous videos. You can go ahead and feel free to check that out. So I'm not going to get too into it, it's just the basics. You know, you take off the housing, you inspect the crank nose to see if there's any damage on the sealing surface, give it a polish up with some emery paper, some 1200 or even Scotch-Brite depending on if it's good condition or not. Clean everything off so that the mating surface is fine. Something interesting with how Toyota's designed their rear main seal housing compared to Nissan is that there's no tabs that the seal bottoms out against. What this means is that the seal is infinitely adjustable in its horizontal position. This means that you can install it at sort of any depth, depending on how much damage is on the crank nose, which is a nice feature. You don't have to fool around and knock in a little spacer behind it. Look at your rear main seal, the new one, and make sure it's the same as the old one. Press that into the housing. Once you're happy with that, throw some gasket maker on the back of the housing, bolt it up, follow the gasket maker torque sequence, and once that's all good, yeah, you should be right as rain. You can do this with the sump off if you want to. It may be better since it does come into contact with the sump, the bottom of the housing does. We've also got to do the spark plugs on the motor, but this is something you can do with the engine in the car easily, so it's up to you if you want to do it now, but yeah, your choice. Next thing we've got to do is install our new pilot bearing. So because the donor engine that I'm using, the 5EZ, came off an automatic equipped car, there's no actual pilot bearing, which is interesting, so you don't have to go to the trouble of yanking out the old one, which can be problematic in some cases. Usually a slide hammer does it. So because there's been no pilot bearing there, there's a little bit of a surface rust or corrosion inside the crank where the pilot bearing sits. So you got to just polish this up with some emery paper to make sure the surface is fine and it's not going to mess up installing it. Once you're happy with how your pocket looks, you can go ahead and install the pilot bearing. Usually you don't have to worry about putting it in the freezer for a while. It may help, but usually you can get by since the actual diameter of the pilot bearing and the internal pocket and the crank aren't too much of an interference. It's usually easy to just knock it in with a little bit of grease or a little bit of oil on the outside of the bearing. When you do knock it in, however, do be careful that you select the right socket size. You want the socket to sit on the outside metal casing of the bearing. If you have a socket that sits on the plastic part or even the internal metal part, what you might do is you might crack one of the rolling elements or even knock some of the rollers out of their grooves where they run. So do keep this in mind, but as you can see, my socket sits on the outside of the bearing perfectly. Try and hit it as parallel as you can, so as straight as you can. If it does start to move to one side, just angle your socket and try and focus the tapping onto the other side to even it out. Don't stress too much, it's fine. You'll see that mine was a bit angled, but I just compensated. And just knock it in until it bottoms out and your pilot bearing should be sweet. Again, just before you install it, make sure it's the right one and make sure it spins nicely, and you should be sweet as after that's been installed. So a cool trick to use when you're about to mount your flywheel is to make yourself up a little thread chasing bolt. So this is a little tool that helps to clean out the threads that the flywheel mounting bolts use. The reason you have to clean these is because when you install the flywheel bolts and you torque it up, you have to use Loctite. Loctite hardens when it's left for a while, and when you remove it, it turns into this sort of dusty kind of gritty little substance, which probably isn't that good to jam new bolts down on top of. So if you make one of these bolts, which is just a shortened bolt with the end cut off and then a little flute cut into it with an angle grinder, you've got to be careful to not let the angle grinder disc dance left and right. It's got to be a sort of clean incision. And what this does is it creates a passage for the bolt to collect all of this debris inside the female thread. And all you have to do then is wind it in and out a few times and you'll see it collect all of the dust and grit. And that cleans up the threads to a point where you should be happy to throw the new bolts down there when you mount the flywheel. So next is the really important part. You've got to make sure every surface that the flywheel mounts to is absolutely hospital clean. The reason for this is if you have any sort of debris trapped between the flywheel and the crank, there's the chance that the flywheel is going to sit untrue from the surface. And if you have something that's a weight of some sort that's bolted in place and balanced from a factory, if you have any kind of debris or any kind of run out where it's bolted in place, you're going to have extreme vibrations, and that would be a massive pain because there's no way you're going to know about it till the entire car's back together and you go for your first drive. So you'll notice that my flywheel has been machined. So I actually did this myself at work. It's a fairly simple operation. All you need to do is bolt it up in a 4-jaw chuck. It's not going to be completely true on the surface or completely flat. So you just go off 4 points, or the 4 jaw points where the chuck is clamping it, until across the 4 points it's 0, 0 or 0.2, which is 0.2 of a millimeter, which is sort of the max I'd allow for. Once you're happy with how it's clocked up, get yourself a nice sharp tungsten carbide insert. I believe I used a WNMG insert, so these are really sharp, really strong inserts. It doesn't really matter too much about the nose radius, probably get a slight bigger nose radius and 0.8mm one. Something interesting to note, what you'll see is that if you put a dial indicator on the tool post and you run it from the outside of the friction surface of the flywheel to the inside, or the closest to the center of the flywheel of the friction surface, the closest to the center of the flywheel is actually higher. It's got more material on it than the outside of the friction surface. So the reason for this is surface speed. You'll know about this if you've had training as a machinist, but pretty much surface speed is the exact same premise as putting bigger wheels on a four-wheel drive. The bigger wheels mean you'll go faster at the same RPM through the differential. What this means is that the outside of the surface area of the clutch plate, because it's a larger radius than the inside surface, in one full rotation it has to cover a larger circumference, meaning that it has to travel faster to do this in one full rotation compared to the inside. And so, long story short, because of this, the inside surface tends to be slightly higher than the outside of the surface, hence why we face this down on the lathe, just to make everything perfect again so that we can put a new clutch on and be happy. All I did was touch the tool just very slightly on the high spot, on the highest point, set the 0 on the machine on the XYZ readout. I came in and I did an 0.5 of a millimeter cut to start off. You can do a bigger one if you want, but the cast iron, when it gets put through a heat cycle, it gets really hard, and there's a chance you might do damage to the insert, and if you damage the insert, you'll just scratch the hell out of the whole surface and have to start again. Be patient. Do it on a low RPM, about 120 RPM. Do it on a low feed as well, probably like a 0.2 millimeter per rev, just to be careful. And yeah, just let it go through and inspect the surface finish once it's all done. And if you're happy with the surface finish, all you got to do is keep taking that same cut until you see full cleanup across the entire friction surface on the flywheel. So anyway, once you've put your flywheel on, go ahead and torque the bolts up in the sequence dictated in the service manual. Once you're happy with that, you can get ready to clean off everything and mount up your clutch. So you've got to be a bit careful. When clutches are transported or when they're sent from the factory, there's usually preservation oil on the faces, and if you don't clean that off, then it's probably going to cause your clutch to slip and defeat the whole purpose of even having a clutch in the first place. So make sure you give everything a really good clean with some kind of cleaning product, thinners, acetone, whatever you usually use. And once you're happy with it, you can go ahead and mount the clutch onto the flywheel and torque it up to the torque in the service manual. I believe the clutch that I used was a blue steel one. It seems alright, it goes pretty well in the car. There was a couple of defects from the factory. There was a little ding on the friction surface on the clutch plate itself, and there was a little bit of sort of material on the clutch that looked like it was frayed, but didn't really care. I just put it on and it worked fine because, yeah, clutch will work, you know. I've reused the clutch in my patrol 3 times now and it's still beautiful. Anyway, once your clutch has been all mounted, you're almost ready to put the engine in the car. A really good tip that I just can't recommend enough to really make installing an engine easy is cutting the heads off some bolts, which you can thread into the threaded holes in the back of the block. These act as guide pins or dowel pins, and these will really make it make it much easier to install the engine and get it mated up to the gearbox. Just put a little slit in the back of it where the head's been cut off so that you can use a flathead screwdriver to unwind them once you've mounted the engine to the gearbox. And as well as this, one of the last things you want to do before you put the engine in is just change the oil filter. I'm actually not too sure how easy it is to access the oil filter once it is in the car. I'm sure it would be relatively easy because it's similar to the 3VZ. However, I just did it while I was out of the car to be much easier, and I suggest you do the same. Anyway, once you're happy with everything, once you've given it a clean and everything looks all good, you can go ahead and lift the engine into the car. Now's also the time to clean the inside of the gearbox out and fit the new release bearing. Make sure you get a bunch of photos of how the release bearing's held on with the clip before you take it off. Because there's a bit of uncertainty, or there can be uncertainty with yourself and even forums as to how the clip's meant to be there. So yeah, just make sure you look properly, take photos before it comes off, and just compare it when you put it back on. Anyway, now you can lift your engine up and get ready to put it in the car. So you'll see me using ratchet straps. I don't recommend this. These ratchet straps are rated to carry, I think it's 200 kilograms each, so they're more than enough to carry the engine, but it's better practice to use a proper sling or a chain of some kind. Anyway, you can go ahead and lift the engine up and over and drop it down into the car now. This process is probably good to do with 2 people. I managed to get the engine into the car solo. However, to actually mate the engine up to the gearbox, I needed a second person. The reason for this is the gearbox, it sort of droops down when the engine's taken off it, as it uses the engine mounts to support it from drooping down. And so when I tried to mount the engine up, I was fighting the gearbox being out of plane with how the engine's meant to sit, and it was just a massive pain, so I ended up calling my mate around. What he did was he stood on the front of the engine crane and pushed against the front of the engine to push it back. While he did this, I was under the car pushing up on the gearbox to align it into the engine so that the input shaft would go into the pilot bearing fine. And this worked out fine, everything slid together and I was able to do up 2 of the bell housing bolts. Before I did up all of them though, or before I even did the 2 up tight, I made sure to do up the engine mounts first, because you've always got to do everything up loosely and then tighten things. If you do things up to full torque, there's a high chance things aren't going to align and you're just going to cause yourself dramas. But anyway, that about wraps up the second video. I apologise that this one took so long to get out as well. I've been on holiday, we've had family from over east come through, and I've just needed to spend a bit of time with them and sort of relax a bit and not work too hard on these videos. If you follow my Instagram page, you will have seen that there's a lot of work going on my other cars at the moment. And I will say thank you very much for 1,000 subscribers. It really means a lot. It's nice to know that 1,000 of you want to learn more and have been taught something by me. It feels good. But anyway, I'm going to leave this video here and get crack-a-lacking on the next video, which is going to be all about wiring in the 5EZ. Thanks everyone for watching. Hope you enjoyed it. Leave a comment, leave a like, and I'll see you all next time.